Hey, you're on ThursdAI. This is Alex. Happy Leap Year Special Edition. Today's February 29th. We had a great show today. So great that I got carried away during the recap, and it's almost twice as long as it usually is. The recap, not the show. But no worries. As always, if you're short on time, the first 25 minutes or so of this almost 2-hour podcast will catch you up on everything that happened in AI this week. If you're using Apple Podcast or any other modern podcatcher, you could also skip to the chapters that I'm outlining every week and listen to the part that interests you and only to that part. This week, after the newsy updates, we also had a deep dive into something called Matryoshka embeddings with the authors of the MRL paper, Aditya and Pratik. And thank you guys. And I really enjoyed chatting with them both. And we geeked out on why OpenAI decided to release something they came up with 2 years ago and how it affects the AI industry post the LLM explosion world. So definitely give them a listen at the end of this episode. A brief TLDR, then a full news conversation you're used to broken down to chapters, and then a deep dive after this brief message from Weights and Biases.
AI teams are all asking the same question. How can we better manage our model development workflow? The path to production is increasingly complex, and it can get chaotic, keeping track of thousands of experiments and models. Messy spreadsheets and ad hoc notebooks aren't going to cut it. The best AI teams need a better solution and better tools. They need Weights and Biases, the AI developer platform, to unlock their productivity and achieve production ML at scale. Replace messy spreadsheets with an automated system of record for experiments. Communicate about model evaluation, and collaboratively review results across the team. Clean up disorganized buckets of models with a unified registry. Automatically capture full model lineage, all the data and code used for training and testing. Seamlessly connect to compute to scale up training, and run large-scale sweeps efficiently to optimize models. Analyze the performance of large language models, and monitor LLM usage and costs with live, customizable dashboards. Get your team on the same page to bridge the gaps from ideation to production. Use Weights and Biases to build, manage, and deploy better models faster.
All right, folks, here we go. Welcome, everyone. Welcome. This is ThursdAI, leap year of 2024. Today is February 29th. Don't get to say this often. February 29th. And this is ThursdAI, your weekly AI news update show and deep dive. We'll see a lot of it. My name is Alex Volkov. I'm an AI evangelist with Weights and Biases, and I get to do this and bring you all the AI updates that we've collected for the past week. And I'm joined here from week to week on stage with guests and experts and co-hosts. I have Yam Peleg with me and Nistan Tahirai, and we're going to have a few more guests later in the show today. And on this very happy leap year, very special day, we're going to talk about a bunch of updates from the AI world, including big company updates, open source stuff. We're going to talk about. All right, so here's everything that we've talked about on ThursdAI for February 29th. This was a great once in a 4-year show. I just want to shout out before I recap everything that, as always, I'm very happy when folks who build the stuff that we talk about join and talk about that stuff. And this also happened today. So we had a deep dive, which I'm going to cover at the end. And also I will shout out that we're coming up on a 1-year ThursdAI stuff, which is March 14th. So in 2 weeks, we're going to have a 1-year celebration. I'm not quite sure what we're going to do with this. Maybe we'll do a give out of GPU credits. Maybe I'll do some other musical stuff. But yeah, that's coming. I'm very excited. It's been a year and it's been crazy. A year of AI. Maybe we'll do a full recap. So with that, everything that we've talked about in ThursdAI for February 29th. We've started with open source LLM, our corner, and we've talked about Google's Gemma update. So last week we covered that Gemma was just released and how the whole community got to start using Gemma and start to think about fine-tuning and support on LLM Studio and LLama and all these things. And Gemma, it's been a week or so that Gemma was out there, and we've tried to identify from the vibes perspective and from the fine-tuners perspective whether or not Gemma is this replacement for the top-running Mistral 7B models that we had, even though on evaluations Gemma looks a little better and performs a little better than Mistral. We covered that it's not really 7B, it's like 8.5 billion parameters. They just counted this differently. And we also saw that from multiple attempts from friends of the pod, Eric Hartford, Technium, Jan was here. It's really hard to fine-tune. The loss curve goes crazy, and we haven't seen like great fine-tunes yet. Something from Hugging Face, from Philip Schmidt, but definitely the fine-tuners community didn't yet take this model and make it like significantly better as we expected that they would. And they're still working on this, so expect more to hear about this soon. And we also highlighted how much Mistral 7B set a very high bar in open source LLMs, and it's really hard to beat, even if you're Google, even if you have a huge amount of TPUs. We then covered briefly an unfortunate announcement from the information from Meta that Llama 3 will not be breaking news in ThursdAI this week or next week. Llama 3 release is probably scheduled to June in 2024, so not anytime soon. And it doesn't look like there's any information as to why that is, so only speculation. So we definitely covered that this news happened. We then moved and talked about StarCoder 2, plus the Stack version 2 as well. StarCoder 2 is from, I think, Hagen Face and the StarCoder team, and they released a new model that beats pretty much DeepSeek Coder before this was the best coding model in this area in the 15 and 7B parameters. And StarCoder 2 is this model that now beats those quite significantly. And together with this, they also released a Stack V2, which Stack is just a huge data set of code from GitHub and other places. And this is like this data set is 10x the previous one. And it also includes opt-out. So you could, if you don't want your code to be trained on and to put into the stack, this Stack V2 includes opt-out requests as well. And definitely a great contribution to the open source. It's 900 plus billion tokens in the Stack V2, which is crazy. And I think there's the duplication, so it reduces a huge data set and supports 600 programming languages, and quite impressive. We then also mentioned that Berkeley, the folks from Berkeley, Gorilla, they previously released work in making AIs retrieve and call functions, and now they released what's called a function calling leaderboard. And function calling leaderboard is very cool because in addition to the MTB embeddings leaderboard that we've mentioned today, and obviously the open source LLM leaderboard on Hugging Face that we all look to and see what's the best performing models, now we also have something that measures the ability of models to do function calling. Function calling started with OpenAI, and then Anthropic added support, and now Mistral added support. So we covered this effort as well, and links will be in the show notes. We then moved and covered Argia or Argila, I'm never sure how to pronounce this. They used the OpenERMES dataset. OpenERMES is the dataset from News Research that is fully open, and you can use this in production without being afraid of being sued. And OpenERMES Preferences is the new largest open dataset for RLHF and DPO, so direct preference optimization. Argia used their distill label feature to actually take every instruction in that dataset and turn into a preferenced instruction where the model would basically learn one or another, which one of the instructions are preferable. So both could be correct, but one could be more preferable. So this is basically a very short version of DPO. And Argia released the largest open source like DPO dataset, as according to them. And they used, interestingly, another news model based on Yi34 to actually create those pairs and those preferences, which is super cool. I love how now open source uses other open source in order to rank and improve itself, which is really cool. So this is everything we covered in the open source. And then we moved into big companies, LLM and APIs. In the big companies, we talked about the biggest news from this week was, if you guys remember, we can talk about Mistral's open weights model in the open source LLMs and open weights LLMs, but Mistral is also now an API provider, and they have this platform called La Plateforme or La Plateforme, and then pardon my very bad French as well. They released a huge model for us called Mistral Large, which we only speculated about whether that's coming at some point as well. And plus, they also released something called Le Chat. And Mistral Large is based on some MMLU stuff, is actually second performing model in the world, getting 81.2% on, I think, MMLU, and second only to GPT-4. So Beats Claude 2 and Gemini Pro. They didn't add Ultra here, so I'm actually not sure how it compares to Ultra, but definitely now is available over API for Mistral folks. One highlight that we've talked about, it handles 32,000 tokens of context. And because Mistral is trying to position themselves as the leader in at least European, this model is native in French and German and Spanish and Italian, and it's definitely well performing in those languages as well. In addition to this, those models, all of the models in their platform now support function calling as well, which is really cool that we now have multiple providers that support function calling. Plus, we have a leaderboard for function calling, so definitely a lot of highlight from what happens in this area. And also, they introduced Le Chat, which is a chat interface currently in beta on top of Ordel models, so you actually can go and use this if you don't pay for, let's say, GPT-4 and you only get access to 3. You can go to Le Chat and try their models out. Shout out to Mistral. They also announced a partnership with Microsoft, and for the open source community, this sounded, hey, they're releasing models, but they're not dropping torrent links anymore. Are they still proponents of open source? And they came out and said, yes, we're still proponents of open source. It's very important for us, and give us some time. We'll give you some more models, basically was the response from Arthur Mensch from Mistral. We also talked about Google teasing Genie, which is a model that makes images into interactive games. And that was really cool to see. I'll add this link to the show notes. It's quite remarkable to see this video from one image of the character in the world. It creates a full world. Imagine like a full Mario just created from one image of Mario. It's quite remarkable. Google also has been in the news lately for the past week or so. We've talked about this, but basically following up of what we talked, where Gemini release was celebrated in some areas because Gemini Ultra beats GPT-4 on different things. It also released a lot of responses online in terms of how it reacts to certain prompts, and it went potentially also affected their stock price. I'm not sure if that was the one thing, but definitely Sundar Pichai, the CEO of Google, sent an email to the whole company talking about how this release was not quite received as much as they hoped, and I'm using choice words here. He actually talked about structural changes and potential review of the whole process of releasing this, and they took down the ability to generate people from the image version of the Gemini model, but they also talked about specifically the Gemini model itself refusing different things. This is in addition to them delivering very well and giving us Gemini 1.5 Pro, which has 1 million tokens in the context window, which I played with this week, and I definitely think it's a great thing from Google. This announced from Google, released in open weights models, and Gemini 1.5 doing like crazy new things, but also the Gemini release at large did not go probably as expected. Potentially the reason why Google took their time to release something for us. We then covered that OpenAI is allowing fine-tune on GPT 3.5, and also the OpenAI response to New York Times and said, hey, we actually did not do the things that you accuse us of doing, but also that New York Times did some trickery in prompts to get the model to respond this way. So the saga between OpenAI and New York Times continues, and that's going to be interesting to follow along. And OpenAI was also featured in another piece of news, and actually two pieces of news. One of them is now there's a conversation that WordPress and Tumblr, both companies from the Automatic company, daughter companies, they will prepare to sell their user data. So basically everybody who had a blog on WordPress.com and everybody who had a Tumblr account, most of this information probably was already scraped and already featured in datasets from OpenAI, but now they're preparing to sell this information to OpenAI and Midjourney. And similar to the Reddit Google deal for $200 million recently announced, WordPress and Tumblr are now preparing to sell to OpenAI and Midjourney as well. And also OpenAI and the robotics company also announced a collaboration as well. Brad Adcock's company will integrate with OpenAI's models as well. Then we moved on to AI, Art, and Diffusion, which had an incredible week this week with two foundational models, or I guess like big new models that are not Stable Diffusion or DALL-E or Midjourney. So the first one was Playground. Playground was an interface. It was an interface for DALL-E and Stable Diffusion, and they built a very nice, a very simple interface that's super fast. You can inject styles. So they used all this data to actually release a new foundational model called Playground V2. And in user preference, this Playground V2 beats Midjourney and beats Stable Diffusion XL and beats the previous model Playground and DALL-E. It looks really cool. And specifically, they talk about their ability to generate photorealistic images very well, and also specifically different ratios of images. So if you think about a standard 1024 by 1024 image for Stable Diffusion XL, for example, or different other sizes, their ability to generate other non-standard ratio models, images, it looks very cool. And in the internal user preference, they actually beat, by user preference, they're showing two images for the same prompt. They beat, their V2 beats Midjourney 5.2 and DALL-E by 9% difference, and the previous model, and SDXL by a significant margin as well. And it looks really cool, and definitely worth checking this out. I'll put a link in the show notes. And the other news that's not Stable Diffusion, Midjourney, or DALL-E related, it's quite a mouthful to say. Ideogram, which we've covered before, announced a version 1.0 of Ideogram. Ex-Google folks who worked on the Google models released a program, like a website called Ideogram, and their approach is very participatory. It's very, I think Instagram is the source of their name, like Instagram for ideas. And they announced a version 1.0 and investment from A16Z. And specifically, it's state-of-the-art on text generation. Text generation is something that we know that other models have, and their model is able to put text very well inside images. So if you want like reactions or memes, or if you're doing presentations, for example, I had multiple creators and characters hold like ThursdAI spaces. I think we had some folks even react as I was talking with generated text images in the comments as well. So this is all we covered in the Art and Diffusion until we got to this like jaw-dropping thing called Emo from Alibaba, which is a tease. It's not a model they released yet, but definitely they released a bunch of videos that were, to me, as jaw-dropping as Sora from a couple of weeks ago. They released something called Emo, which is a way to animate faces, to take an image and create a singing or talking face. And it's not only the face, like the shoulders move and everything. So animate an avatar based on one image. And I will not be able to do it justice because I'm still collecting my jaw from the floor, but definitely I will add some links and some videos. And the coherence with which these models generate talking faces is just incredible. It's not only about animating the mouth, they animate eyes and eyebrows movement and even different other things like hair and earrings. And one last thing that I noticed that really took me a second was they even animate the vocal cords and the muscles in the throat where somebody sings, for example. And when I saw this, I was like, this is another Sora moment for being able to create with these tools. It's really incredible, and I really hope they release this in open source so we'd be able to animate whatever we created with Sora. And we covered all of this, and then we had a deep dive with Aditya Kusupalli, Pratik Jain, the authors of L paper, Matryoshka Representation Learning, and they talked to us how recently OpenAI released a new version of their embedding model, and you are able to specify the number of dimensions you want, and many folks didn't understand what this is and how it works. And apparently, even though OpenAI built all of this from scratch, it was based on the paper that they released almost 2 years ago called MRL, Matryoshka Representation Learnings, and we had a very nice chat and deep dive into how this actually works and how they pack the information, the embedded information from later on dimensions into some of the first dimensions. If you're interested in this area, and this area is very hot, I definitely recommend you check out this conversation. It was really great, and thank you, Aditya and Pratik and the rest of the Matryoshka team for joining and talking to us about this new and exciting field. And I think we started already chatting a little bit, and I see some folks from Hugging Face in the audience sending sad emojis, and I want to send hugs to the Hugging Face MLOps team yesterday, because for many of us who now work with Hugging Face, and by work, actually, our code includes a bunch of imports from Hugging Face. There's transformers as well. Yesterday was a realization of how big Hugging Face is now part of many of our lives. I think that for the first time for many of us, this was like such a big realization, because that imports stopped working and the downloads didn't actually work. And so we actually had a long space yesterday, pretty much throughout the whole downtime, as we were holding each other's hands. It reminded me, I don't know, Yam, if you want to chime in, but it reminded me previously when GitHub was down. Basically, you could work, but if you can't commit your code, what does it help? And I wanted to hear from you, because I think you had some models queued up for some stuff, and then you were waiting for them.
Yeah, look, Hugging Face is really the hub today. It's not only for using for most people, I think. It's because they cannot fork or clone models from Hugging Face. So they cannot do many things that they do because your code relies on getting the model from Hugging Face. This is why, by the way, they tweeted, just for anyone that doesn't know, you can work offline. If you ever cloned a model from Hugging Face ever, you probably have it already on your computer, so you can just use the offline version. So there is a command for that. But for many people, it's cloning the models, but for many other people, is also the feedback that you get from Hugging Face. I can tell you, some other people here in the stage, that we submit models to the leaderboard, try to fine tune better and better models. And for us, it's also the feedback of what is going on, where models shine, and where we need to make them even better. And for me, at least, I had 4 models that I waited for results for, and many other people as well. And just shout out to Hugging Face for actually doing it. I'm running evals locally, and I know how heavy it is to actually run them and how much compute it takes for how long. And it's amazing to see that they have such a leaderboard with so many models. It's amazing. It's hundreds of thousands of dollars of compute to actually create such a leaderboard. So it's amazing to see. And they provide it literally for free, where the community is growing every day. So it does cost. So huge shout out for them.
I was trying to prepare.
We are all addicted.
Absolutely addicted. I was trying to prepare yesterday for this space, and part of my preparation is reading X and Twitter, and but definitely part of my preparation is going to Hugging Face, reading the model cards, reading the leaderboards, for example. I was trying to count in my head how much stuff we're getting for free from Hugging Face. And one such example is just their blog, which was also down, which I read specifically to prepare for the Matryoshka conversation today. And that's just like a huge resource on its own. There's the whole conversation piece where there's the hub, but there's also the conversations. AK posts papers, for example, they post them on Hugging Face, and then there's a whole discussion threads about them as well. That wasn't accessible. Leaderboards themselves weren't accessible. And just the amount of compute, like you're saying, that they throw at us for free to be able to support this open source is definitely worth a shout out, and definitely shout out to engineers there that brought the hub back. Nistan, what are your thoughts on this?
Yeah, without Hugging Face, this place turned into a flea market for models. People were asking, does anyone have Quant 72? And I was like, no, I have the finetune. And then the dev lead of Quant 72 pointed us to some Chinese site where they can download it. It was pretty funny. That
ModelScope is not just some Chinese site. ModelScope is where I think most of the Chinese folks are posting their models. It's like I think modelscope.cn, I think, is the alternative on the Chinese area. So there is at least a backup for some Chinese like models, although I think you have to translate that website, right? But yeah, I don't know. We had a conversation yesterday, and Pharrell was also talking about datasets, where many folks just upload the dataset, don't keep a local version of it locally, and then to be able to run evaluations or do different things like this, that also was prevented yesterday. Definitely yesterday we discovered how big Hugging Face became part of many of our lives, and it was a sobering realization. But I don't know, for me, like I saw people complain online, and I get it, folks. I get it. Sometimes you complain, but honestly, sometimes, as far as I understood, the downtime wasn't even their fault. There was like a Mongo thing in AWS. I'm not sure. I didn't dive in deep. I just... when this happens in my head, when I dealt with downtimes before in my professional career, nothing but appreciation for the team to work hard. And I think Yam, Clem, the CEO, even responded to you when you said Hugging Face is down, right?
To many people, not just to me. But yeah, they are responsive.
Responsiveness and like
absolutely
being in the community and saying, hey, folks, we understand, we're sorry about this. I think that's basically... Besides having folks work on this actively, which we know they had, this is all we can basically ask for. So I'm just sending positive vibes and appreciation. I saw some people getting salty. I saw some people saying, oh, this sucks and we need a backup. And I was like, yes, but also this doesn't mean that you can ignore everything for free that we've got so far from this incredible organization. So shout out. And I don't work there, but I do have many friends who do. I think, Nissan, go ahead, and then we'll move on to actual recap of everything we're going to talk about.
Yeah, and same for the leaderboard. We give Hugging Face so much crap when things don't work. And I really appreciate that it's actually the CEO that responds directly to your complaints and tickets, and it's not just some like support person. No, it's Clem, is the actual CEO. They'll respond. They're the first ones to respond. So that's pretty amazing. You don't really see it in other companies. Like, we don't expect the president of Microsoft, Brad Smith, to ever respond to a GitHub issue. Could you imagine that? So yeah.
He is not your favorite. I would love Satya, though, to chime in on the discourse, but not Brad. Yeah, absolutely cannot imagine this. And kudos to them for the participation in the community. And I guess we should start with our usual thing, open source. So I guess let's start with open source. Open source AI, let's get it started. All right, folks, this is our regular update every week for the open source corner, where we're going to start with, interestingly, Mistral is not in the open source corner, is not featured in the open source corner today, but we'll mention them anyway, because from last week, if you guys remember, Gemma was released. It wasn't open source, it was open weights, but definitely Google stepped in and gave us 2 models to run. And since then, I just wanted to mention that many folks started using these models, and there's quite a few stuff that I'm actually wanting to hear from you about, because we talked about this. The Gemma models are not necessarily 7 billion parameters, right? This was a little bit of a thing, and also about fine tuning. Could you give us like a brief out, like how the last week in terms of Gemma acceptance in the community was?
Oh wow, Gemma is giving me hard time. This is for sure. Fine tuning Gemma or at least struggling with fine-tuning Gemma for a week at the moment. So starting from the beginning, Gemma is not exactly 7B. The way it is referred in the paper is that the parameters in the model itself, apart from the embeddings, are exactly 7 billion parameters, but then you add the embeddings and you're a little bit over 8.5, if I remember correctly. Which is fine. I don't think anyone has any problem with a bigger model. Just I think that it'll be more genuine to just say it's an 8B parameters model. It's fine. That's first. Second, it behaves differently than what we're used to with Mistral and Llama. I'm not sure why. Maybe someone can tell me, but I'm not sure why it behaves differently. And many people are currently working and struggling to fine-tune it better. So this is where it is at the moment. I've seen already Orca. Someone fine-tuned on Orca and didn't get great results. I also heard that Hermes, someone fine-tuned on Hermes, I think from news. I'm not sure, but I think. Also, results are not great. I'm continuing pre-training, and the loss is doing whatever it wants. It goes down, and then out of the blue, it starts to jump. I'm not sure exactly why. It might be because the architecture is slightly different. There are slight modifications. So maybe it's that, or maybe something else. But yeah, I think we're still exploring the model. We don't have an answer yet.
Yeah, that's what I got as well. I pinned a few examples of Eric Hartford from Dolphin Fam. I think he now works in Abacus, and Technium as well tried to do some stuff. And all these losses look crazy. All these losses look like jumping around up and down. I saw a tweet from Philip Schmidt from Hugging Face where they were able to fine-tune some stuff, and the conversation from Eric and Wing Lian from Axolotl. And there looks to be an effort to try and hone this thing and see if actually fine-tuning this on some stuff. The Hermes stuff, fine-tune, was not really like an official news research thing. It looked like somebody just took the data set and folks weren't able to actually get it to run or perform well as far as I saw. I haven't seen an update from this, but I definitely follow up with news. So I would just remind folks, last week we talked about Gemma was well received. Everybody hopped on board like super quick and added support. LM Studio and LLama added support like super quick. Wing started adding support to axolotl for fine tuning. Hugging Face added support in, I think, transformers. There's a bunch of TreeDAO added support for flash intention. There's a whole community effort to receive Gemma as much as possible. And they also released some stuff in quantized versions from Google. So very good effort from Google, and then very big acceptance from the community. But since then, what I'm trying to highlight is a lot of the stuff that we've talked about, a lot of the way we judge models, whether or not they're good or not, is if they're fine-tunable, for example, is one thing, but also if they're instruction following, if it's easy to converse with them. I haven't seen any of this come across my timeline at all. I will be frank, I only interacted with the 2 billion parameter model and wasn't impressed. It's great that we released it. I would not be using this for any of my workloads. Nistan, do you have any other feedback as well? Specifically around like how Mistral 7B seems to be still a good alternative, even though it's performing less on evaluations.
Yeah, I feel like we have been spoiled by just how high of a bar Mistral 7B has set for everyone, that it even made Mistral Large feel somewhat unimpressive, although it was answering everything perfectly well. But yeah, not only has it set a very high bar, but it was also very easy to work with. So the amount of innovation that came upon the community, just building off of the initiated weights, has made this class of models extremely competitive, that even Google has a hard time cracking through. That yeah, our expectations now for a 7B model are extremely high. Like, it has to run on my phone, it has to do what I want, it has to respond, it has to summarize stuff, it has to carry forward the conversation. Oh, and it has to score high on the benchmarks too. And this pace of innovation that the community has set upon this is just very hard, and also incredibly interesting to see that Google is having a very hard time matching or getting close.
Specifically because in the land of GPU poor and GPU rich, in the original article that defined the two categories, Google is the GPU/TPU rich, right? They could and have thrown a bunch of compute at these models, and still the folks from Mistral, a team that's less than 30 people that started 8 months ago, released a model 6 months ago. I think Mistral 7B is around 6 months ago, right? September. That Google 6 months after, with all the GPU richness, is very barely able to match, not to mention beat significantly, which is unlike any pace that we're used to. We're used to a 7B model beating a 70B model week after week. And here's a huge company coming out and saying, hey, here's our best attempt at the 7B model that Yum doesn't even consider a 7B model. And it's in at least our attempts to play around with this, it's not beating significantly, which is strange, but also not being able to get fine-tuned very easily. Very interesting and very a highlight of how much quality the Mistral model was. I will also say that Arthur Mensch, we'll cover this in the Mistral section afterwards, but he came out and he said something and basically said, we can only do so much with 1500 H100s. 1500 H100s. Just by contrast, Meta announced a few months ago, famously, Zuckerberg came out and said by the end of this year, they're going to have 600,000 worth of equivalent of H100 compute, 600,000 H100s to train and host and probably do inference on Meta and Llama. And this is like 1,500 H100s that Mistral was able to use and fine-tune a model that Google cannot wipe off the board completely. It's very crazy. Moving on to basically another news update that's not a news update. We've been waiting for Llama 3 for every week. I've been saying, hey, it could get released here and etc. There was a leak from the information. I actually don't know it was a leak or not, but the information came out and then a bunch of other companies followed with this news where Llama 3 will be released, I think in June. This was the update. Llama 3 will not get updated and released for us anytime this year. We were hoping for a 1-year anniversary. Llama 1 was released in February 2023. And now we're not going to see Llama 3, even though it's like it finished training as far as I understood, or as far as updates were. And while Zuckerberg goes and eats at McDonald's, Llama 3 will not get released for us. I wanted to hear folks here on stage react to this because surprising news, isn't it?
I'm just gonna say that I called it. Just based on how it's censored and unwilling to answer anything CodeLama 2 was. So yeah, if CodeLama 70B wouldn't answer anything, I figured it would be around the same for Llama 3. So now they either have to go way back in the training when they started doing a lot of this and retrain it with it being a lot more obedient, but still not horrible or anything, because we see from Mistral's team that it does obey to you and respond stuff, but it still won't tell you like how to kill your cat and stuff. So it's the public backlash from people giving it to Gemini and Google has completely affected the Llama 3 release, which is just very interesting.
Interesting, because they did release Llama 1 and then nothing bad happened in the world, and then they released Llama 2 with a commercial license that people can actually use this, which kickstarted a bunch of open source stuff, and now they're waiting with Llama 3. Potentially I heard some stuff where it could be GPT-4 matching model that we could run, but we don't know until it released, but just like a very interesting update. And I gotta wonder if by the time they decide to release this, if other open source will catch up or not. Usually Llama, when they come out with a big model, it's impressive. But for example, Llama Code already was beaten by the time it came out, right? If I'm not mistaken, like DeepSeek Code and other models achieved the same score on coding that Llama Code was released with. Maybe waiting a little bit. I gotta wonder what goes into this decision. Which, on the topic of code, I think we're moving to the next thing. And StarCoder 2 and Stack V2 were released, and in collaboration with Hugging Face. Stack V2 is like the second iteration of the Stack dataset, which was just like insane amount of code collected. I think Stack V2 now includes opt-outs, so you could say, "Hey, I want my code to be opted out from the Stack V2," and so this new dataset, I think, is 60 billion parameters, I want to believe, 10x more than the first stack. And StarCoder, the 15 billion parameter model, it beats CodeLama 13B pretty much on every human eval plus and DS100 and GSM 8K. Very impressive. It beats obviously the previous StarCoder, which was a very significant model. I think based on the evaluations, DeepSeek Coder we know was like one of the best code models so far, and it looks like StarCoder on a few benchmarks competes with, but everything else it beats DeepSeek Coder as well for the 7B model, but it's a model twice the DeepSeek size as well. So they released 3 models, 3 billion parameter, 7 billion parameter, and 15 billion parameter versions. 15 billion parameter is a very interesting place where you could potentially run this still on your Mac if your Mac is stacked up and get a decent result back. It has a 16K context window, a very weird one, usually like 16384, weird one. It was trained on 4 trillion tokens, depending on the size of the model. Includes 600 plus programming languages, which is great. All we care about probably is Python and JavaScript, and maybe some folks care about Rust, but 600 plus programming languages. I honestly didn't even know there's that many. Percent of human eval, which is okay. I've seen models like get way better than 46%, so that's interesting. And what else is interesting in DeepSeek? It's commercial-friendly license, so you can use this for commercial stuff. You can be used for local copilots, which is something we're waiting for, and the more of this, the better. And yeah, StarCoder 2. But I also want to shout out that the Stack V2, like the more data we'll get, the better it is for everybody else and other models as well. And the Stack V2 is definitely a great achievement that we should shout out.
Yeah, this is crazy. The full data set is 67.5 terabytes for the Stack V2, and you can just have it for free.
Yep.
It's the amount of work. So it's 900 billion tokens extra that went on top of what was actually an excellent coding model to begin with. So this is huge. Not just beneficial from the model itself, but also because you can just, I don't know, fine tune one for TypeScript if you want.
Yeah. Go ahead.
Yeah, I think it's worth mentioning that as far as I haven't looked at it in depth because the Hugging Face was down, but as far as I understand, it's a base model. When we compare human eval of a base model to a model that was specifically fine-tuned to obey instructions, and we see a result that is, okay, it's not the same, but it's somewhere at the ballpark, it's amazing. Because it just means that as soon as you will fine-tune, it's going to be incredible. Moreover, from what I've seen at the paper, I heard about it and I was sure that I'm going to open the paper and what I'm going to see is something like, hey, we did the same thing, but huge, 4 trillion tokens, enjoy. But no, what you see over there is that they really went in depth into the benchmarks themselves and checked which benchmark is actually, what exactly does it measure, how it correlates to real life usage. They went over there and benchmarked different packages, like each and every one, like how good is it with matplotlib, how good is it with scipy. And this is a very detailed and high quality work. It's very hard to say which is better as a base model, DeepSeek or StarCoder, because there are so many benchmarks at the paper I've never seen before. Even DeepSeek has, I think, 6 benchmarks. StarCoder, I didn't even count. There are so many, and I think it's great work. Even I suppose that the model is really good, at least on the level of DeepSeek. Although I don't know, I need to check. But just the paper alone, it's such a huge contribution. The paper alone and a data set. So yeah, it's amazing. And it went a little bit silent. People just release models that are trained on 4 trillion tokens and it goes silent nowadays. It's amazing that we got to something that's insane. And on the same week, NVIDIA released a model. I don't think they actually released the model, but they just trained a model on 8 trillion tokens. And we don't even talk about it. It's just insane.
Let's talk about it. I saw the NVIDIA stuff, but I didn't see a release. I saw an announcement, right?
Yeah, it was a paper. And I think that's about it. NVIDIA is showing they got the best hardware because they got the best hardware. So they can train on a lot of tokens really fast. And the model is really good at the end because the tokens. But yeah, I'm just saying that it's increasing. And the amount of data is increasing. The size of the models that we actually use are increasing. And it's worth noting that there is a trend of things getting more and more powerful.
Absolutely. And I would just say this is partly what we're here for, to highlight things like this in the open source and shout out the folks who worked hard on this, on releasing this and making sure that this didn't go silent, because this effort is very well appreciated. If it's a base model, then we'll get local co-pilots performing way better. And this is great, especially the data set that they released was like 10 times the size of the previous one. It's called the stack, and folks would be able to use this to fine-tune other models, and that's obviously also great. And on the topic of data sets, if you guys remember, we've talked about Argia multiple times at this point. Shout out Argia folks, and if you want to come up and talk about Argia, your place is here. They released a DPO conversion of Technium's like Hermes dataset. It's called Open Hermes Preferences. And as we've talked about news research and Hermes multiple times, this is one of the data sets that I think 1 million rows that compiled from different other data sets as well. And Argia is an open source tool that allows you to make data sets better by converting them to preferences and DPO. So they released the DPO version, DPO's direct preference optimization version, where basically they take a data set with a regular RLHF data set with one instruction in a conversation and turn it into kind of a preference where they show a few instructions and they actually have information about what would be a more preferable instruction. That's what very poor explanation of DPO. Yam, if you want to chime in here and clean this up, feel free. And Argia released an open Hermes preferences, which is 1 million preferences dataset on top of Technium. And it's pretty remarkable because we know that even news research, when they release DPO versions of their models, it performs better than a regular SFT fine-tuning models on top of every benchmark pretty much. And now they've converted all of that data set into a preferenced data set. They've created the responses with another Hermes model, which is pretty cool, right? So they're not using OpenAI because scraping from OpenAI is against, as we saw in the lawsuit with OpenAI, it's against the terms of service. But you can actually create these preferences with another model. So they're using new researchers Hermes to Yi on top of Yi 34B to do what's called a distill label and make those instructions a little better. And this dataset is open. So unlike the regular, I think, Hermes, this dataset is open for you to also go and fine-tune your models, which is pretty cool. And shout out to the open Hermes preferences. I'm going to pin this to the top of the space. And I will also definitely add this to the show notes. No. Okay, let's move on in our conversation. I want to talk about the function calling leaderboard because I think it's pretty cool. Let me just go and find this tweet real quick. This is from, it's actually, yeah. There was an effort before called Gorilla, and now the same folks from Berkeley released a leaderboard called Berkeley Function Calling Leaderboard. And essentially, function calling for those who don't use any open source model, but use something like OpenAI. OpenAI, during last summer, I think, answered everybody's request to give us structured outputs in the form of JSON and answered them with, hey, we're going to introduce something called function calling for you, where you call our model and you provide one function or several functions in your code, and the model will respond and say, hey, you should call this function and with these parameters. And basically, instead of getting JSON mode, we got function calling back then. Now we have both. We have a way to get just structured JSON, but also we get models to respond with which functions we should call. And this is great for agents. This is great for folks who are building with these models. And I think during the summer, because OpenAI came up with this concept, OpenAI was the only model that was supporting this. And then quickly, open source started catching up. And I think, Nissan, correct me if I'm wrong, but I think John Durbin's Ouroboros has a bunch of like function calling instructions in it. So this model, and then models who are trained on Ouroboros were also fairly okay with function calling. Mistral just released their update. So Mistral supports function calling.
They have about 1,000 of function calling datasets in the Ouroboros 2, or I forgot. Just look up John Durbin, Jon Durbin, and Ouroboros, AIROBOROS dataset. And yeah, apparently there's about 1,000 entries in there for function calling. That's by accident helped a lot of the other models be better at function calling too.
Yeah, so every other model that was trained on Ouroboros, which is a lot, Hermes includes Ouroboros dataset. They now, I don't know if this is by accident or this is now how things work in the merging world and in the fine-tuning on top of datasets that fine-tune on top of other datasets, right? But definitely other open source models now support at least the notion of function calling. And then eventually we get to the point where there's now a leaderboard like we like. So if we're going to talk about embeddings later, there's a MTB leaderboard for different embeddings model, even though I see Bo in the audience and he's not very happy with how easy it is to game this leaderboard. We obviously look at the open source LLM leaderboards, and Yam was talking about submitting a few stuff there and see how it performs, and that's being exploded in popularity and merging. So it's great to have a function calling leaderboard as well from folks at Berkeley that tests models, I think API only. I don't know if they're supporting open source at this point. The test models and looks at how you could expect a performance on different function calling. And I think for folks who are building with this, it's very cool. So some of the models that are leading this leaderboard, and GPT-4, the latest preview from January, is leading this. They have something called Open Functions V2, which I think the organization that pulled this up, Gorilla LLM, is the folks who put it up, and they have an Apache 2 license, and they have an average score on different simple function, multiple functions, parallel functions, different scores for all of these tasks. And I want to highlight this and I want to add this to the show notes because more and more we see Mistral Medium entering there, Claude from Anthropic, and open source models. And I think for many folks building with these models, this type of interaction with the model is very important, where it's not only a textual prompt and you get something back, you actually need to do something with it. And I think shout out for folks for building and maintaining this leaderboard. And I think they also released the Gorilla model as well. Let's move on. I think this is it, folks. I think this is everything we have to talk about in the open source LLMs. And given that Storm is in the area of open source-ish, let's cover Storm a little bit. I think this is a good time because it also dances on the area of interest that we talked about last time. Do you want to present Storm and talk about this and see how cool this is?
Yeah, cool. I guess maybe let me say one more thing on the Gorilla.
Yes,
I think
please.
it's fascinating going through the functions that they have. If you go through the open function, the blog post from Berkeley, you have calculate triangle area, and then you give it the base and the height. And I think that kind of just like super specific functions, having a massive data set of that, it's fascinating that they've seen this next evolution of that. But okay, so so with Storm, yeah, and there's definitely some intersection between DSPy and the function calling models. With DSPy, one of the built-in signatures is that React one, where React you have thought, action, and so it's one way to interface tools. Yeah, the tool thing is pretty interesting. I think it's also really super related to the structured output parsing and the please output JSON and JSON, our favorite influencer of the function calling.
I just want to make sure that folks don't miss this. Jason Liu is the guy who you're referring to, and he's our favorite influencer in forcing these models to output JSON. I find it really funny that a guy named Jason is the guy who's leading the charge of getting these models to output JSON formatted code. I just find it really funny. Didn't want to skip this. I wanted to plug that joke somewhere, but please go ahead and let's talk about Storm. Oh, and shout out to both Weights and Biases and Connor on Wave8. Jason appeared in both places talking about instructor library and how to get these models to give a structured output. So definitely shout out for Jason for this. Check out his content on both platforms.
Mm-hmm. Yeah, awesome. Yeah, it's such a huge part of these LLM pipelines. Like I know Bo's going to speak in a bit, who's someone I consider one of the experts in information retrieval. And one of these big things is like you will retrieve and then you'll re-rank and then you'll generate. And if it doesn't follow the output exactly, you can't parse it in the database. So it's such a massive topic. But okay, so starting with Storm, I guess I can tell a funny story about this. Erica and I were hacking on this, and we came up with the plan of you start off with a question, and then you do retrieval, and so you're looking at the top 5 contexts as well as the question, and you use that to produce an outline. And again, structured output parsing, that outline better follow the comma-separated list so that then you can parse it, and then you'll loop through the topics, and then we have a topic to paragraph prompt where you're doing another retrieval now with the topics, and then we have the proofreader and then the blog to title. So that's the system that we got our hands on with, and I could probably talk about that better than the Storm system, but it's very similar. With Storm, so the difference is we're retrieving from a Weave8 index with Weave8 blog posts, as much Weave8 as we can. But like they replaced the specific retriever with web search retriever. And so I was playing with that a bit on the weekend as well, using the u.com API as the web search. And it's pretty cool. Web search and as well as a private thing that you curate. I think that's definitely one of the big topics. Okay, so then the interesting thing is once you've got this, in our case, is a 4-layer system, now you use DSPy to compile it. So what compiling it entails in DSPy is tweaking the task description as well as producing input-output examples. So you have in the prompt, you slightly change it from, you'll take a topic and write it into a blog post. Typically, that ends up resulting in a blog post about software documentation, right? So that's what that ends up looking like. And then the input outputs end up being like an example of what are cross-encoders. Here's a blog about cross-encoders. And so you can use that input output to then reason about the new inference. And so hopefully that's a good description of what it means to compile these programs, where you optimize the prompts for each layer in the task as you decompose this task into its subtasks. Storm then introduces something that I think is pretty novel, which is how you do that research loop. So we naively just went question to outline and then just instantly flesh out the outline, whereas they instead go from question to perspectives about the topic, and you retrieve from each of the perspectives about the topic, and then you'll write it, and then it will, I'm not sure how it all gets resolved, but it's almost like a multi-agent system in my view. This kind of like perspective guided, it's adding personas or like background. So I think that's probably the key differentiator between Storm and then that kind of like blog post system that I described. But so we have open source code on Weave8 recipes if you want to see what our 4-layer program looks like, and compiling that with the Bootstrap optimizer. With the Bootstrap optimizer is you just run a forward pass through the model with a super high capacity model like GPT-4, and then you get the input output, and then you hope that Turbo or one of the cheaper or the open source models, of course, can look at those input output examples and then copy the system behavior. There's a lot of other interesting things about this, like multi-model systems. Even in the Storm paper, they compare GPT-4 and GPT Turbo, and then they use Mistral 7b instruct as the judge. Another thing is, like earlier talking about re-ranking, you might want to have the long context models do re-ranking, because with re-ranking, you typically try to give it a lot because you're trying to like put a band-aid on the search. So you probably want to have 20 to 100 results that go into the re-ranker rather than 5 to 10. And it's probably also not really a task for LLMs anyways. And I think that's another opportunity for a task-specific model. But overall, to conclude this thing about Storm, I think for me, the big exciting thing is it's becoming, DSPy is making it super clear, I think, on how to build more than chatbots or just simple question answering. I think we're probably within a few months from anytime you have a pull request, the documentation will be written for you automatically. Probably you could even have an idea and have a pull request created by the model. I'm personally biased by these kind of coding applications, but yeah, this kind of like long form content generation by breaking down each task and then optimizing each part of the task. It all just really interests me.
Very interesting. And I added the Storm from Yijia Shao to the show notes as well. And folks are definitely worth checking out because it writes like Wikipedia length articles and uses like u.com API or different other search APIs to give perspectives and references, and very interesting. I want to, in the sake of time, I want to move. So just like to reset the space, we've been at this for almost an hour. You guys are on ThursdAI. ThursdAI is the weekly podcast and newsletter that's recorded live on X Spaces, and I'm here with several friends and guests and experts in different fields, and we've been covering open source LLMs until now, and I think we're going to move into big companies because we need to cover this, and soon we're going to have some folks to do a deep dive about embeddings, and let me just make sure that the folks know that they can come up. The big companies, LLMs, and APIs. This is the segment where we chat about OpenAI and Microsoft and Google and whatever, not the models that they release for us in open weights and open source that we can run ourselves. This is the segment where we talk about API and developments and different updates. So let's run through them. The biggest one from this Monday was Mistral releasing Mistral Large, which we've been waiting for and getting excited about. And also they released a chat version of their models called LeChat. And it's very impressive, folks. Like the Mistral Large now is, based on at least some metrics that they released, is second only to GPT-4 and beats Claude Anthropic and Gemini Pro on the MMLU score. And Mistral is vastly superior to Mistral Medium. It handles 32K tokens of context, natively fluent in English, French, Spanish, German, and Italian. It highlights how much Mistral is focusing on becoming the OpenAI alternative from Europe, because you can go to LeChat and there's execute every chat that you have with their models, and basically maybe you don't have to have an OpenAI subscription. I think that's what they want to do. But also this model is available in the API, and it's significant performance on top of everything else on the other languages. And they're aiming for the 5 top languages in Europe, obviously. And I think it's a very standard, like a very important move from theirs, that they're establishing themselves as this big company. This was why we moved them to the big company APIs as well. The announcement also includes something interesting. They said we have also updated Mistral Small in our API to a model that's significantly better and faster than Mistral 8x7b. If you remember, when we talked about Mistral releasing API access, we said that whatever Mistral next is, it's probably going to be medium. So now we have a large model that outperforms pretty much every model besides GPT-4 on different tasks, according at least to them. But also the small model that's like faster and better. They upgraded this like behind the scenes. They're not released any of this in open weights, which is the response from the community was partly this, is Mistral releasing a bunch of stuff and none of the stuff like we expected. No torrent links this time, no open models that we can start fine-tuning. And I think, so first of all, kudos on this release. I've used some of the stuff in LeChat and I'm very happy with the responses. They're fairly quick, but definitely giving good responses. Nistan, I think your perspective from before, from the open source segment, is very interesting, where they spoil us so much with the open models, with the Mistral models and even the 7B, that even large doesn't seem that significantly better. However, just on the metrics, it looks like we just got another competitor in the ring. From now, there's Google Gemini Pro, Anthropic Claude keeps releasing models that are less performant, at least on LLMs, than the previous models, and now Mistral not only doing fully open weights open source, but also in the API. And if folks want to build on top, they can. An additional thing to this, they also released a partnership with Microsoft and announced that these models are also going to be distributed through Azure. And I think this is a big deal for companies who maybe don't want to trust a startup that's less than 1 year old from Europe, for example, and maybe their servers are in Europe. Maybe the companies don't want to trust their ability to stay up because there's like only 30 people, or enterprises, they need more stuff like ISO and different things. And so I think it's a big deal that Microsoft is now also supporting and giving us access to kind of these models through Azure, and especially for companies that want stability. Not stability, just stability in general. I want to just mention that if you guys remember, after Dev Day, OpenAI went down for a week. Or not a week, but there was like a whole period where OpenAI had a lot of issues on production, and the Azure version of OpenAI stayed stable. Obviously, Microsoft wants to sell their cloud, and I do believe that it's a very big deal that Mistral is now supported through Azure as well. In addition, Microsoft also announced a small stake in Mistral, and Arthur, the CEO of Mistral, went and clarified. So first of all, their new website with these announcements, again, didn't include some stuff or included a note that you shouldn't train on this, right? And then our friend Pharrell here, for the second time, called them out publicly. And for the second time, Arthur Mensch, the CEO of Mistral, came and said, whoops, gone. And so it does seem like an omission rather than something they put on purpose and then they remove after Twitter calls them out. Pharrell, thank you for that, for noticing. But also some other folks noted that their commitment to open source, which we discussed before, was gone from the website, and they put it back. And so now, like prominently on their website, even though this time they didn't release any open source, any open weights for us, this time their commitment for open source is prominently featured on top of their website. And now there's 2 segments there. One of them is optimized models, they call them, and one of them is open weights models that they release for the community. As we talked previously in the open source segment, their models from 6 months ago are still competing with something like the new and cool Gemini Pro 8 billion parameters.
It's still 32K context window, by the way. So
yeah,
I measured, and after that, it completely forgot. And also, it was okay. I was expecting as a chat model to be way more chat optimized, but it does feel more like a base model. And yeah, again, I said the comments before. We're too spoiled by all the 7B and mixtral fine tunes and merges, that now this is extremely good and is very utilitarian, and if your business needs it, you should use it because it provides reliable answers. It's not, we were just expecting more.
So one thing definitely to note as well, and we mentioned this a little bit, but definitely worth mentioning. So the smaller model is now better upgrade. So if you play with this, they also upgraded the pricing for this. And I would also caution folks, the tokenizer they use is a different tokenizer. So sometimes when you measure tokens, they may look different. Our friend Zenova here in the audience has a tokenizer playground in Hugging Face, which, by the way, with the rest of Hugging Face also went down yesterday. So I went to check just the length of a string. I wasn't able to. It was sad. But now it's back. So that tokenizer, I think, measures OpenAI tokens length. And Mistral, I think, has a different one. So when you calculate pricing for use, definitely make sure that you're calculating the right thing. Yes, no, you're welcome to come up and tell us about this. So one last thing on Mistral is that it supports function calling as well, which I think is a big deal. And we mentioned this before in the function calling leaderboard. And now Mistral models can also respond to your RAG applications or whatever with actually the functions you should call, which is, I think, super cool. And the industry moves there, and it shows again that OpenAI can come up with something a year ago and basically set the standard for how things should look. I actually don't know if Assistance API is going to be like this, but I do know that, for example, we talked about Grok, and Grok supports the OpenAI standard. And many of these, I don't know if Mistral does, but many of the, like Together API and other, I think Perplexity as well, all of them have their own version of their API, but also you can just replace whatever code you wrote for OpenAI with just like a different proxy URL. And then you basically use the same structure that OpenAI innovated on. So that I think is pretty cool. Moving on
go ahead. Just a note is that the OpenAI pip package allows you to actually call any URL. It doesn't matter if it's OpenAI or not, which actually uses that standard. It is very easy to drop in any replacement to the OpenAI APIs.
Yeah, including local ones. If you use LM Studio, our friends LM Studio, shout out Yags, or Olama, I think, both of them will expose like a local server when you run the open source models. And then you can put in your code like your local URL that runs the server with the local model. And then your code will also work, which is, thanks for all. This is like a very cool thing that people may have missed. The same can be said, by the way, about Copilot. It's a little harder, but basically you can replace the Copilot infrastructure in VS Code with like local models if they support it, if you go to settings. But moving on to Google Tease's Genie, right? Google Tease Genie, which is quite incredible. You take one image of something that your kid drew that has like a character, and then you provide this into this like video type text to video or image to video model, and in response you get like a full world that is interactive and looks like this character is kind of in the same style transfer and looks pretty much the same. The character is like interacting in this world. Seeing this is unbelievable because it just shows that we're very close to being able to take one picture and start animating this. And very worth like adding this to the top and adding a video for this. It's really hard to explain in words, and I haven't read any of the paper, but Genie was really like also mind-blowing as well from Google. And they only teased it, so we don't know actually if they're going to release this. Pharrell, you wanted to comment? I saw you.
Yeah, sure. It's if any of you have watched Centex's YouTube video like a few years ago about GameGAN from NVIDIA, it's basically GameGAN but with generative AI, and it's pretty awesome because it means that we're all headed towards the direction of basically interactive rendered worlds, and Sora is one extreme end of that with really high quality text to video. But then what happens when you actually add actions into the loop? And that's what basically Genie does. So we're probably going to see the marriage of both methods, both architectures very soon. Very exciting work for sure.
And so I think most of the open and big companies stuff we covered. One quick thing before we move on. OpenAI opens up fine-tuning for 3.5, and also OpenAI is in the news again this week because WordPress and Tumblr, basically, I think both of them are the same company, Automatic. They're preparing to sell user data. It sounds scary, but honestly, it's all public and probably was scraped anyway. And still, they're preparing to sell this, probably more structured and maybe more licensed to OpenAI and Midjourney. So that's very interesting because Tumblr had a bunch of images and probably was scraped to an extent. WordPress, definitely. So just to clarify, this is not WordPress, the platform where everybody can use the open source platform to run their websites. That's not what they're selling. I don't think they can. But WordPress.com, I think, is where you can host a blog for free without knowing how to raise a WordPress platform. So WordPress has the open source system that you can run your blogs and websites in that runs like 30% of the internet, something crazy like this. But also WordPress.com is the place where you can host your blog. And basically, when you signed up and created your blog there, you maybe didn't know the information is theirs to sell. So like Reddit supposedly selling Reddit's information to Google for $200 million that we talked about last week. Automatic is now basically trying to extract money based on their data, where previously this data was scraped. What's the benefit for OpenAI? Obviously, now there's a lawsuit with the New York Times whether or not this is considered fair use and whether or not OpenAI's models can spit out full New York Times articles. So there's a whole debate about this, and there's going to be a lawsuit because they didn't achieve a similar deal with New York Times, although it was reported the folks from OpenAI actually did talk with New York Times to try and have more of a structured access and licensed access. And WordPress is definitely a huge chunk of the internet, and now some of that information is going to go into these models in a more structured and licensed way. And moving on to diffusion models before we jump in, because there's a bunch of updates there, and I think Genie takes us a little bit into diffusion models. So let's see if we have a thing for this. Yeah. AI art, diffusion models, text to video and images, and everything in between. Only on ThursdAI. All right, so As I said before, we don't cover this at length. I know there's a bunch of other spaces for AI, Art Diffusion specifically, but when we do, it's because something very big happened. And this week was a huge week as well. And so I just want to shout out that we had 2 foundational models basically, and then another thing that just broke my jaw, and we're going to talk about this. Playground from the previous Suhail Doshi, I think is his last name. He previously was in Mixpanel. He started building a browser called Mighty, and then he switched fully into AI. And I think a year ago started working on Playground. Playground is an interface that like super fast and lets you generate a bunch of images, and it's just an interface on top of, or at least previously was an interface on top of DALL-E and Stable Diffusion. And they kept giving away for free all of these models and image generation, and basically they collected, they added styles, etc., and they've collected all this information of what people actually do preference on. And now they released an open model, a new diffusion foundational model, which we haven't had for a while. If you guys remember, we talked about SDXL Lightning, which is based on SDXL. We've talked about Stable Cascade, which is also related to stability. We haven't had like an open model for generating images in the wild for a while, and Playground released their model called Playground V2.5. And the cool thing about this is that they say, first of all, it looks great on realistic stuff. Secondly, they say that on user preference on internal 1,000 tokens, they significantly beat the baseline for DALL-E, for Midjourney, for the previous version of Playground, and SDXL as well. And by significant, they beat internal preference again. SDXL 1.0 gets like 17%, and their model, the new model, gets 82%, which is like a quite stark, like a big jump in capability and improvement as well. They also get improvement on top of Midjourney, the latest of 5.2 version, which Midjourney is like really good and realistic. And so what they excel at is realism and just different. I think they also mentioned different ratios. So if like most of these image models, they've been trained with certain 1024 by 1024 for SDXL, for example. And when they generate something in a different ratio, it looks different. So they also claim that their model is actually significantly more performant at different ratios as well. Definitely shout out to Playground folks for working on this awesomeness, because who's going to say no to another model? And there's a demo from, I think, Model Labs that actually makes this work really fast. If you guys remember last week, I talked about a thing that I built with SDXL Turbo and Grok. And obviously SDXL Turbo is super fast, SDXL Lightning is super fast. Compared to those super fast examples, the Playground image generation is just night and day. It just looks so real. It's quite striking. So if you're looking for any updates in that area, definitely check out Playground. And I think because it's a model they released, you can use it for free. The only thing that I don't know about is the support in the community kind of stuff, if it supports Comfy UI or some stuff like this, but they just released it, so I'm sure support will come. And obviously the LoRa's and everything else in this community is very interesting to see. There's also a Hugging Face demo. And then the second thing in image generation, real quick, is Ideogram. Ideogram, we've talked about before. It's a startup that came out of folks who worked on the image and stuff at Google, and apparently weren't very happy with the slowness of the release. And while Google and its image generation is suffering from bad news and is in hot water because of different prompt injection that they had, and even we didn't mention this, but mentioned this in the beginning. Sundar Pichai released an email to all of Google and said, hey, we had mistakes, we offended some of our customers, we need to do organizational changes, which is not a small thing from a head of the company to admit this bad of the release. Ideogram was created with folks from Google before, and they released it for free. And I think they just announced Ideogram 1.0, and the best thing about this, I think, is just text. Everybody is focusing on different things, but if like all these models, they generate text to some extent. DALL-E can do text, but it's not like perfect. Ideogram's text generation is super cool. So far I used it multiple times just to answer somebody on X, reply with just a text, for example. Like for Hugging Face, I think I sent them like a thank you note with just text. And it's really cool to have a model that's like very good at presenting and generating text with the imagery that you want. So Ideogram 1.0, they also announced a investment from A16Z, and really their text looks super cool. I was able to do something that not other models could do. I was able to ask it to generate a hashtag ThursdAI, And if you think about this text is not in the training set because, we came up with the concept, and a hashtag like confuses these models. And I think this was the first model that was able to actually not screw up hashtag ThursdAI fully. Cherry picked still, so 3 out of 4 still wasn't like perfect, but definitely this is the best text model that we have. Ideogram, check it out. Yeah, go ahead.
Just randomly in the audience, I noticed we have one of the creators. I think it was one of the top 10 Hugging Face spaces pretty recently. So they're the data out of GPT-3. And they also have what's called a DALI 3 dataset, training dataset. But yeah, they released a new model recently too. I posted it up, Proteus. So if we have some time after the interview, maybe we can bring them up and stuff.
Yeah, let's see where our second guest is. Oh, he said he's going to join in 10 minutes or so, so we have a little bit more. And the last thing that I want to cover, and actually want to go to my profile and paste this because you have to see this. And if you haven't seen this, okay, so first of all, I'm going to post an image of, I'm adding this onto the show notes now, is the last pinned tweet, image of very happy sheep that all say we're doomed. And no, this is not the one. I said this sure does. Hold up. Yeah, this one, we're doomed. And the text there is really cool. And the cool thing about the text is style transferred into the image itself, so it looks like part of the image. But this is not what I want to post. I wanted to post the jaw-breaking video from Alibaba from a model that they teased and hopefully will release soon called Emo. And folks, I don't have a button for this. I don't have a musical tradition. I will just say that if you remember, and if you were here on ThursdAI when Sora was announced and released, if you guys remember, this was live, I think 2 weeks ago, we had Sora release and we were just like freaking out live on stage here on ThursdAI because like our jaw was collectively breaking from what we were seeing. Sora showed a significant jump in capability for image to video or text to video generation and coherence throughout the scene and longer generations. And since then, OpenAI has been Sora posting. That's what I call it, Sora posting on TikTok. So if you're on TikTok and you don't follow OpenAI, they literally opened a full account that just posts Sora videos or Sora posting on TikTok. And since then, the amount of videos that they released there just shows the capabilities of that incredible model. It does look like the ChatGPT moment for video generation based on what they released. I think that Emo from Alibaba is definitely one of those moments. And actually, it's really funny because the Alibaba folks took one of the Sora generated videos. If you remember, one of the main ones is a woman, not the main ones, one of the first ones is a woman walking through Hong Kong wearing sunglasses and it zooms into her face. All of this video generated. It's quite crazy that we're now like, oh yeah, of course it generated the woman walking to Hong Kong wearing glasses, but it's still mind-blowing. So the Emo folks from Alibaba, they took that video, took a still from that video, just a still, not a whole video, and made that exact woman sing Dua Lipa song. And this is now pasted on top of the space. And folks, my jaw dropped when I saw this, and then dropped again because I started looking at all the details. I did a little deep dive into image generation, avatar creation, basically taking an image and making it sing or lip sync. And usually those models, they move maybe the mouth a little bit, some of them move the eyes. This model makes this from one image only. It makes the eyes move independently, it makes the eyebrows move independently. Obviously the mouth. I saw earrings get animated. I saw vocal muscles in the throat get animated, where if somebody talks or sings, you can see their throat move differently. I'm noticing all these things. The woman in the video that I'm referring to wears sunglasses. So most of these models would move the sunglasses to an extent. These sunglasses like stayed exactly the same place. So the coherence of this model is way beyond anything that I've seen. And I've researched this field and I used DOD, DAD, I used WAF2Leap, I used all these like tools. And just the creation would be able to use with something like Sora plus something like this Emo thing. It just opens new horizons. And many of my friends in AI art are looking at this and like in disbelief because it really feels like the Sora moment as well. So I wanted to highlight how exciting this was for me and how huge of a jump this was from everything we've seen before. Reactions from folks on stage. What do you think when you saw Emo? Same as me? Existential dread? Anything else? Yeah, same as me. All right, so it looks like Nissan, go ahead and I'm going to take a look.
I just want something like this that's like small, real time, and cartoonish. So I just use it as an assistant. That would be great. Oh. I'm impressed, but I just want like a small, tiny one. I want Clippy. I want the actual Clippy.
They didn't animate Clippy, but I found it very interesting that they animated the Sora-generated woman with the voice of Mira Murati, the CTO of OpenAI. They like took her voice and embodied one of their creations with this voice, and I found this like very interesting choice on their part. I will say, while Aditya comes up, Aditya, if you can hear me, I'm sending you a request, and if you cannot, oh yeah, there is. I found it very interesting that they haven't released the model yet, but they did say we're committing to open source. We're going to release this, and their GitHub for Ego is open, but there's no commits there. It's just like a README. So hopefully they're going to release this, and hopefully we'll get to a point where we can actually, listen, like you're saying, have a actual assistant in near real time with a fake voice or generated voice actually read out whatever LLMs tell us. And I think this last thing I'll say here before we move on to the interview is this adds to this notion that I think we saw from Logan from OpenAI, where a chat is not the final interface for these things. I think embodiment like this is one thing that moves us forward. All right, folks, this has been the updates, and now we're moving to a more of a deep dive interview, and I'm very happy to introduce two guests here, and two guests, I'm getting a little winded, so forgive me, but I want to say hi to Aditya Kusupati and Pratik Jain. And thank you. And folks, feel free to unmute yourself and talk and call out. But basically, welcome Pratik, welcome Aditya. How are you guys?
Yeah, thank you, Alex.
Thanks so much, Alex. And thanks everyone for listening.
I'm going to set this up. And I think, Pratik, I noticed you on my timeline first, and then I saw Aditya's tweets as well, where we've talked about OpenAI's new embedding models, and one of the things that was like very interesting back when they released this, and this is how I got to talk with you guys, is they added some new parameter in their new models. So they had ADA002 before, and then they said, hey, we're releasing two new models, embeddings version 3, and they have a way to specify dimensions. And so previously on ThursdAI, we talked about embedding models. We talked about the MTEB leaderboard that Hugging Face has. We have folks from Gina AI that also released like top of the line embedding models as well in friends of the pod. And we definitely looked at open source models and in comparison to something closed source, like for example OpenAI, and dimensions were a big thing in that whole area. Then OpenAI released something that you can specify number of dimensions, and this raised an eyebrow and was like, oh, that's interesting. I don't even know what this is about. And then I think, Pratik, I saw your tweet saying, hey, congrats OpenAI. Unfortunately, you didn't mention us. And then somebody from OpenAI reacted and said, oh, actually, yeah, we do use something called MRL, and they added this to the blog post. Pratik, could you talk about that before we dive in on what MRL actually is? Could you talk about what they added and why? And yeah, just talk about this phenomenon of them not adding you to the blog post.
They had done the work on their own and everything. It's just, and they did release like really strong embeddings, like the results on MTAB eval boards looked really good. Definitely many congratulations to them. Only thing was that they had released this new thing, as you mentioned, called shortening embeddings. And the output structure in some sense seems very similar to what Matryoshka representations or these nested representations do. And we do know that they were at least aware of Matryoshka representations because through some of our earlier conversations, at least some of the research scientists had reached out to us and had talked to us about some of the details about Matryoshka representations. So it's felt a little bit like against the spirit of open science and pushing a scientific boundary. So that's the only reason we highlighted that it would be good if either the initial work can be either cited or maybe use the same name. I think they were very gracious. In particular, the person who had written the blog, I think they said that, yeah, there was a miss on their part and they have updated the blog. All good. I think when we do open research and publish and discuss ideas, I think it moves the field very fast and helps everyone. We are definitely all up for it.
Yeah, absolutely. I want to talk about when you guys released MRL. This was way before the explosion of LLMs and ChatGPT came to the scene, right? You released MRL, Matryoshka Representation, back in 22, right? Almost 2 years ago, like a year and a half ago?
Yeah.
And so talk to us, maybe give a brief explanation of what, like, I think folks are generally okay with embeddings in the audience here, but maybe dimensionality is still somewhat of an escaping field. Would one of you tackle the task of explaining what dimensionality means in a very like popular science way so we can then dive into how adjusting dimensionality actually helps performance and different things?
So generally what happens is if you have, say, some text data, right? So let's say you have a string of 1024 tokens, or let's say you have an image, a 64 by 64 image. What computer in some sense would want to see them as a set of numbers or a vector of numbers. Through this incredible line of work around embeddings, what we are able to do is we are able to embed these images or text or whatever data object you have into a fixed dimensional vector. So by that, what I mean is you might have a 64 by 64 image, but you can write that as a series of, let's say, 128 numbers, right? So that is what we call dimensionality. That is, it is 128 dimensional vector that we want to work with. Why is this interesting? Because if you have a 64 by 64 image and you just change some pixels, let's say only 1% of the pixels, those changes would not even be visible to you. But when you compute, let's say, the distance between these two images along pixel space, that is, if you just subtracting two images from each other, pixel by pixel, the distance might seem very large. But in reality, semantically, both of them mean essentially the same. So what we ideally want is some of these embeddings which capture the underlying semantic structure of the data object of, let's say, image. Let's say there are two images, both of them contain cat in very similar pose. We would want to have them being represented within our machine as very similar sort of objects. And that is what these embeddings or semantic embeddings are able to do. So generally, there are multiple techniques to take, as I said, either the image or text or audio, whatever you have, and embed it into, say, a fixed dimensional representation, that is a fixed number of floating point or integers. Now, generally, these representations are like rigid, they are fixed. That is, let's say a designer has to a priori say that, okay, I can deal with 128 dimensional representations for my image. And on basis of this, I can run some sort of classifier or some sort of retrieval algorithm to retrieve similar images or classify the image into some particular class. So generally, that decision is made a priori that I will be forming it into 120 dimensions because 128 dimensions, let's say, are able to give me the accuracy I want, and I will be able to deploy them in my system, because that's another sort of key part. Whenever you are deploying them, the dimensionality of the model of the embedding can be a critical thing. Let's say if you want to do retrieval, the cost of retrieval is almost directly proportional to the dimensionality of the data point. So the decision is made a priori. So for example, like earlier embeddings that came out from OpenAI, they made that decision that, okay, these embeddings should, let's say, be, I think, 1024 dimensional or something like that. So you just had those 1024 dimensional. And not so good part about that is that now everybody who wants to use those embeddings have to change their system to suit their 24 dimensional representation. So some people who might be running, say, some sort of retrieval engine on 64 dimensions, they will need to now scale up everything, change how they are doing retrieval, how their indexer works, how their serving works to fit to those 1024. And that's not ideal, right? So the idea behind Matryoshka representations was that can we bring flexibility in these embeddings? That is, while we are giving out 1024 dimensional embeddings, can somebody come and read off just 64 coordinates out of it so that they don't need to change their entire serving stack?
So I want to slide in here with a question before we get to your guys' solution in dimensionality, flexibility, which is very cool. So you're saying the a priori decision basically means that I, as a developer, let's say, if I used whatever OpenAI has given me or any other rigid structure, I had to basically abide by their rules of how much they decided, how in depth those embeddings represent my concepts, correct? And could you talk about, maybe before we dive into like dimensionality, how this affects actual retrieval? Is more embeddings always better? There's a thing that I heard yesterday that somebody mentioned. It's called the curse of dimensionality. And I really wanted to dive in and hear about what this means. Is because we've talked before, and there are embedding models with like 8,000 dimensions or so. And I heard from Bo, who's in the audience here, who may join us as well, that's not always the best case for many reasons, not only speed as well. Could you talk about the curse of dimensionality, and is more always better?
Yeah. So that's a great question, right? So definitely more dimensions intuitively should help you capture more and more information about the data that you are trying to embed. Obviously, like beyond certain point, it starts to becoming complete noise, right? So for example, even if we go back to the image example that I was giving, you have a 64 by 64 image. You can think of it that as a 3600, like about 3600 dimensional vector, right? And if you want like a very precise embedding, then maybe that 3600 dimensional vector is what is capturing everything about that image, because that is rough. That's precisely how we are seeing that data point, right? But the bad thing about that sort of representation is that it is not capturing the semantic information. It is also bringing in a lot of noise. There is some sort of sweet spot at what kind of dimensionality of data you want to stop at, right? That's one part of it. But when you come up with these representations, they are going to be used in some downstream task, right? As I mentioned earlier, some of the downstream tasks are, I have this representation of the image, now do classification for me. So I will run some sort of classifier on top of this representation of the image to say that, okay, whether this image has a cat or a dog, right? Similarly, I can say that, okay, I want to retrieve most similar image to this given image in my database of all the images. So I might have an entire database of animals. I give you an image of particular cat, and I want to retrieve a cat which is most similar looking, maybe in similar pose, similar situations, right? So these models or these embeddings are used in this downstream task. And to use them in these downstream tasks, we are also then bound by the realities of those downstream tasks. For example, if you want to do classification and you have only, let's say, 200 data points to train the classifier, then a very high dimensional embedding is not great, because that will then give you very poor performance. Like your model will overfit. It will just like mimic whatever it is seeing on training data, and it will not generalize to new test points. So it can be catastrophic. Similar situation happens in even your retrieval or nearest neighbor search kind of thing there. That is, if you have very high dimensional embedding, as you mentioned earlier, like there is this curse of dimensionality that applies, which might mean that my nearest neighbor search is not working well, especially if I'm doing any kind of approximation, and I might get essentially garbage of that situation. So that's why, based on the downstream task, the amount of training data I might have, the serving realities there, that okay, how much latency I can spend or how much compute I can spend in serving, I might have a sweet spot into that. Okay, this is the dimensionality that works best for me, and I ideally want to select that and work with that.
I see. And Aditya, it looks like you can now join. I also wanted to follow up with you because Pratik is talking about, and Pratik, the examples you gave are image embeddings, and that's great. But I think one of the huge things that happened since you guys released the paper is how much LLMs are being used for different things as well, right? And I think this led to an explosion in vector databases, and they store embeddings. And I think, at least for many of the developers who use these like LLMs, text embeddings, or at least they started with text and now it's like multimodal. This is like the highest use currently in RAG. Would you, maybe Aditya, would you want to expand on how much this whole field started heating up with like vector databases now storing every embedding? I definitely didn't hear about this up until a year ago. Would you want to like chime into this and how your work is now like super relevant to this whole new world?
Yeah. As Pratik said, I think curse of dimensionality even applies in vector databases because you have to search through things. And the major thing is you also need to think about storage, right? So let's say you want to index 1 billion documents, and if you want to do everything with say 1024, you're going to have to use about a terabyte or 4 terabytes worth of data for storage. And a lot of people might not be willing to do that. So how people typically do that in vector databases is they store one copy, and when they're trying to do some processing on top of it, they do some sort of compression. It can be a lot of things, and it works great. But the thing is, it's a lot of post-processing, and you also need to store the actual embeddings in your vector database store. I think with the data which keeps growing and growing, and there is no way for you to control the total amount of data, you should probably figure out a way to make your representations much more compact, much more accurate. I think that is where a lot of oversight was there for the last few years. Again, vector databases existed even before last year, but they blew up because of the RAG applications. And I think in Matryoshka case, as OpenAI said, it gives you the flexibility to just store 64 dimensions if you want, and that should just be it.
And 64 is way smaller than the previous dimensionality that they said. I think 1053 or 1024 or so. And also, yeah. I would be remiss if not to mention that video is coming into play right now. Like these large multimodal models now, they're not only understanding text and images. Now, like we're talking about video embeddings, for example, and being able to represent those. And when you talk about storage costs, etc., dimensions definitely affect that. And also speed of retrieval and comparison. So Aditya, let's move on to talk about, because you guys wrote the paper before this explosion, but definitely the concepts existed. I want to hear about what Matryoshka representations is and how it affects dimensionality, specifically from being able to choose during which process. And I would love to hear from you the brief explanation, then we can dive in and ask more questions.
Sure. Let's take the running example Pratik said. Let's say there is a 1024 dimensional representation of your image, or let's keep it to 1024 for now. And so you're trying to basically fit a bunch of learned attributes. So it could be some version of color, some version of texture, etc., which is being fed into these things. So that is what these embeddings are learning. And they're extremely good in a lot of semantic tasks. If you want to find a similar looking dog, it's much more easier for you to search in this space. So that's the goal, right? Ideally, until now, when you wanted to do things faster, you took these embeddings and you did some sort of compression, most likely some notion of PCA or low dimensional projection or some sort of quantization, okay? And that's how you used to do it. So there is an additional processing overhead on top of the existing embeddings for you to get this done. We wanted to fix this problem because this additional overhead need not always give you the most accurate solutions. So the motivating goal for us was to figure out if we can pack the information in this 1024 such that we don't have to project it into low dimensional space or do any post-processing to get a 64 dimensional embedding, but rather just take the first 64 dimensions of this vector. So if there is a collection of 1024 numbers, I want you to be able to cut it off at the first 64 and say, this is a 64 dimension embedding, which is as good as any 64 dimension embedding you can ever build. That makes sense? And this was the goal. So this is the final embedding should look like this. And that is what we try to do. And it turns out training these things are so simple that it's literally what you think. If you want the 64 dimensions of the first 64 dimensions to be the most important thing, you optimize the same loss function you're doing for 1024 on the 64 dimensions. Let's say you're doing some text embedding training where you're trying to pull two relevant text embeddings together and two irrelevant text embeddings farther. And there is a loss, which is typically contrastive, which tries to do this in 1024 dimensional space. At the same time, when you're doing this 1024 dimensional space, you also do it for 64 dimensional space. That's it. So you now have two losses instead of one. And at the end of the training, which again does not take any other extra cost than as if you're training a 1024 dimension embedding, will give you the first 64 dimension embeddings, which are as good as any 64 dimension embeddings you can ever trace. And that's pretty much it. So you can repeat this for multiple dimensions. So not just 64, you can do 64, 128, 256, and so on. Now you have this chunks of representations inside this 1024, which can cater to a wide variety of audience, depending on their use cases. And a lot of times people don't care about precision. If recall is all you care about in your retrieval applications, you can just use 64 dimensions. And if you want more precise information, as Pratik said, you can encode more information in higher dimension embeddings, go to 1024. If you have lesser number of data points and you're not able to cluster things properly, go for smaller dimensions. So the flexibility just opens up so many things which were probably infeasible before in hand because you had to do some sort of post hoc compression or pre-processing on top, post-processing on top of it, and which led to slightly lesser accurate things. So it just didn't allow you to do all of these things on the fly.
Well, just to sum up to see if I understand this, I'm looking at, and unfortunately this medium is audio only, but I think it's very helpful to see visual representation of this. You're basically front loading most of the important information in the first 64 dimension, 128 dimension. And you're saying that precision for specific use cases like RAG could still be as good as like with 124 dimension. And that sounds to me incredible.
Let's take an example, right? Like in your RAG, all you care about is 10 blue links, which need to be in the top 10. That's it. You don't care if the first link is the first one or the last link is the last one. There is some evaluation saying that there is a utility for positionality, but most of the cases, if you get 10 relevant documents in any order, that's all that you matter. You don't care if the best document is at the top or at the 10th link. So if you feed in all of these things into your LLM will figure it out. So this is the case of recall. You don't care about precision. So your ranking only cares about getting the most relevant 10 documents in the first 10 and not how relevant they are within themselves.
I see. I want to also...
add a little bit more nuance there. Sorry, just to add a little bit more nuance there. In many situations, what might happen is in your RAG, rather than even getting, let's say, top 10 links that suppose I get top 100 links, right? And those top 100 links, some of them might be completely useless, completely rubbish. But as long as those correct top 10 links are somewhere there sitting in top 100 link, I'll be fine. That is, after that, I can do refinements. The rough structure here would be that you will take, let's say, only first 64 dimensions or coordinates, or maybe only first 32 coordinates from MRL and do those retrieval of top 100 links. Once you have those top 100 links, to get the correct top 10 links, we can do then further rescoring based on full, let's say, 1024 dimensions and get like those things. And now because everything is nested, those embeddings are already computed and I have with me, right? So I can first say that, okay, for the first phase of getting top 100, I can use 32 dimensions. And then in the second phase of doing that rescoring, I can use full dimensionality. Sorry for cutting you.
No, that was great addition. And I want to think, rescoring and re-ranking, are you referring to the same thing? Like some folks like take the initial results and then they try to rank like what's the most appropriate ones. I think, does this represent the case that you guys talking about, where the initial information is not really necessary for the first responses, and then we're going to run another tool like Cohere? Sometimes those folks do re-ranking with Cohere, and then you'll like judge the importance of those and then sort them in a secondary process.
Yeah, that's a relevant thing, but I think Joe Christian Brigham is in the call from Vespa. Like, he's a proponent of late interaction, so you can do a lot of other re-ranking methods. But in this case, what Pratik specifically is saying is, let's say you recall with 64 dimensions, and you can rescore with 1024. You can use the precise 1024 to just rescore in case you ever want to use it. And this is all from the same MRL embedding.
All right. So moving on, I think, Aditya, I heard you say also that in the use case of LLMs, for example, where again you guys built this before the explosion. In use case of LLM and RAG, some amount of this is offset to the LLM itself. After you retrieve and you provide this data to LLM, it can do some of this work for you, which I guess why your work from a year ago or a couple of years ago found newfound relevance. But then I think you followed up with another paper a year ago and add ANN, right? Could you talk about how this applies to Matryoshka embeddings as well? I would love to hear additional work in this area that you guys did.
Sure. When Pratik was talking about retrieval, he also mentioned that you typically do a nearest neighbor search. So the goal is when a query comes in, you embed it into the same space. Documents, say, let's say 1 billion are encoded in the same space. Your target is to find, say, top 10 documents which are most relevant. And the way you do it is nearest neighbor search. So you just try to find which vectors in your database are the closest for queries. But the thing is, again, as Pratik said, like the cost is directly proportional to the dimensionality as well as the number of data points. So it's linear in terms of number of data points and dimensionality. So to reduce this cost at web scale, so there is no way Google can ever serve things if every single data point has to be explicitly compared. So there's an idea called approximate nearest neighbors, which has been there for the last 25 years or so. The goal of approximate nearest neighbors is instead of touching all the 1 billion points to get top 10, I'm going to touch, say, something like 10,000. So I'm only going to search 10,000 by somehow partitioning the space and only cleverly looking at the places I want to look at and get to the 10,000. And in those 10,000, I'll do more exhaustive search and find the top 10. Okay, and this is the approximate nearest neighbors. And the simplest way of thinking about approximate nearest neighbors is a tree structure. So you have 1 billion points. You basically are building a huge tree structure by using clustering. So 1 billion points can be clustered into 50,000 clusters, which can further be clustered into 50,000 each. And eventually your leaf nodes, like the final leaf node, will have 100 data points in each of the leaf node. And this is a typical tree-based data structure, which a lot of people use for approximate nearest neighbors. In case anyone is interested, you can go check Phase library from Facebook. It's a very good resource for all of these things. This is approximate nearest neighbors, and it plays very well with web scale systems. You want any of your embeddings to play well with approximate nearest neighbors if you want to scale to web applications. While powerful, Can you hear me?
Yeah, we can hear you. You cut off for a second, and now you're back.
Okay, so Matryoshka representations, as Pratik said, again, like you can use 64 dimensions for shortlisting of 100 documents and re-ranking for, say, with 1024 to get the top 10. This is, while sound in principle, when you try to do this in systems-aware settings, this does not scale well because these 100 documents need not be sitting on the same machine. They need not be collocated, all of these things. There's so many systems considerations which start blowing up. And approximate nearest neighbors directly handles this. Approximate nearest neighbors ensures that similar documents are in similar chunk of your memory for your systems to take care of a lot of these things. So we wanted Matryoshka representations to power better approximate nearest neighbors. That's why we came up with ADANS, or adaptive approximate nearest neighbor search. And the goal here is, again, it's when you're doing approximate nearest neighbors from 1 billion to 50,000 clusters followed by 50,000. Let's say you have a 1024 dimension embedding. You use the same 1024 embedding for every single one of these phases. But as we talked earlier, if you only care about recall, which your clustering is basically doing, what your clustering is saying is, look, I just need to be in the right cluster, right portion of your space, and that's pretty much I care about. So that's just recall. And if I'm able to do this clustering with 64 dimensions instead of 1024, I can save a lot of compute when I'm searching the space. And this is the idea. So at every single level of this tree, I'm going to change the dimensionality I'm going to use. Let's say 64, 128. And then finally, when I come to leaf node, when my query goes to the leaf, I'm going to precisely re-rank all these 100 data points or so with 1024. So there is going to be a precise re-ranking at the end, but all the intermediate steps, because they're already approximating, but only care about recall, can be approximated with a lower dimension embedding. You can traditionally do this even without Matryoshka embeddings, but you need, again, post-hoc compression, which is not pretty great. So Matryoshka representations just gives you this for free. So if you want 64 dimensions for first phase of clustering, take the first 64. If you want 128 for the second phase of clustering, take the first 128. And that's the reason it becomes seamless, and that's what ADANS does.
Awesome. And I want to take this to the practical level a little bit. As far as I saw, sentence transformers from Hugging Face supports this natively right now, right? You can import and you can encode embeddings in different models. What other tools, since you guys started getting a lot of interest like after this, both because of the LLM explosion, now everybody does RAG and everybody understands that RAG is one way to get these models to behave as they want. What else? What other tools? You mentioned FICE. What other tools are now supporting something like this? Because on the face of it, it sounds very, very helpful, very performant. In my head, this sounds like not necessarily direct, but like similar to how quantization came and reduced the precision of models, and basically they respond with the same precision, but they're significantly smaller. So, what other tools can folks find use in Matryoshka from what you guys have heard?
Yeah, two clarifications. Face does not use Matryoshka right now, but ADANS was built off of Face. So yeah, that's a caveat. So they don't use Matryoshka at this point. Yeah, second thing, you asked quantization, right? That's a very good point. Quantization is a complementary thing. So think of quantization as flexibility in your bit precision, while Matryoshka is flexibility in your dimensionality. So both of them can work hand in hand even after this. So you can quantize any Matryoshka embedding and it will still play well with quantization. So that's the beauty of this, right? Until now, we are only reducing the precision of the numbers, and now you can also reduce the vector itself. So that's very good. Coming to the repositories and other stuff which are using, of course, sentence transformer, I think, is going to be the easiest way in. I went through the implementation day before yesterday. It's pretty clean. It just works out of the box. Nomic released the V for 1.5. If anyone wants to go and look at it, inside, again, it's 10 lines of code, beautifully written, and I think it's much more understandable in case someone wants to get into the weeds. So that is one thing. We have our own repository, which we released like a couple of years ago. But the nice thing about Matryoshka is if you want to train something, it's literally a for loop. It's 4 lines of code. So the code is already in the paper. If someone wants to go and implement it, you just look at the paper. There will be a code in, I think, page 12 or something, 5 lines. You just go and implement it. Apart from that, I think Transformer.js was supporting a bunch of these re-ranking visualizations in Hugging Face. But yeah, like for now, I think these are the things we know which are supporting. ADANS, I don't think anyone is supporting at this moment. It's just our code base which is out there. It's also not highly optimized for low-level things. So I wouldn't recommend you directly use it for your use cases, but it's a great thing for you to prototype and see how well you could benefit from this flexibility in retrieval space.
So I just want to make sure that we shout out properly AI, the folks that have the Atlas platform to visualize, and they downsample, I think you said, like they lower the dimensionality into 2D or 3D space to actually show dimensions. They released Nomic Embed 1.5 recently, like a fully open source embedding models end to end, and they're great. And now they're also supporting Matryoshka, which is great. I also heard you say that quantization directly applies here as well, so you can like I don't know the verbiage of this, like you can Matryoshka something and quantize a model, and this will result to significantly smaller and like smaller weights. So that's great. You also mentioned the Transformers.js, which is a Hugging Face library, the author of which Joshua Zenova is here in the audience with us, friends of the pod, that supports this as well. Folks, we're slowly running out of time a little bit. I wanted to thank you for coming up. It often happens when folks who build something come up and talk to us. It doesn't often happen in something that released a few years ago that now resurfaces in popularity, and then we're able to highlight some folks' works. So Aditya and Pratik, I really want to thank you. Anything else that you want to mention before I recap the whole space? Feel free to. Definitely not a full deep dive, but I really wanted to highlight the fact that your work is now represented also in like one of the big libraries in the world in terms of AI, and many folks can now understand what is this parameter that they do when they adjust dimensionality in OpenAI's embedding models.
I think Nomic, the reason why I say this is a straightforward implementation is Nomic released their V1, and then Matryoshka became a thing. So they literally trained this entire thing in 3 days and with all of their data. So it's extremely simple, and they actually had to not change a single hyperparameter. So it's pretty good. I would like to see if Pratik wants to add anything, but otherwise, thank you for having me here.
Thank you, Aditya.
No, it's pretty accurate. Thanks so much for having us here.
Awesome. So
Yeah, and
go ahead.
For anybody else in the audience, sorry, I've posted the links as to what you can do with this. So it's Zenova's demo when you can use it in Transformers.js. And also we look forward to actually implementing the paper too. Because again, this is not a very well known or well discussed subject in general.
So I'm very happy to have been able to host you guys, and you have a paper out, I think it was in Europe, and seeing more from the space of embeddings, because there's more to come here, and many people are now using this in big production. Probably it was used in Rexes before, but now in big LLM related production stuff. And the more folks understand retrieval and fine-tuning retrieval, and also ways to cut costs like Matryoshka, for example, it would be great. So shout out to you guys. Definitely thank for working on this and coming and showing, giving light. I'm very happy that you did get the mention in the OpenAI, and I'm happy that I noticed because of this and was able to talk to you guys and figure out what Matryoshka embeddings are. And if folks want more deeper deep dives, this was like very surface level. Aditya and Pratik, you guys did a paper club with Latent Space yesterday, and before that, both Weviet podcast talked about Matryoshka embeddings. Connor was here before. You guys just missed him. And also Hugging Face. I think Nistan put this link up. Hugging Face has a very nice deep dive from Omar and Zenova about Matryoshka embeddings and what they mean and how to use them in sentence transformers. All right, folks, this has been our ThursdAI for today. I will now take a deep breath and recap everything we've talked about. If you've been here for the past 2 hours and you've probably heard all of this, but if not, feel free to stick around, and it's probably going to take me like 8 minutes or so, and then I'm going to let you go. With that, this is our ThursdAI for February 29th. Leap year, February 29th, like once in 4 years. I found it pretty funny, and I think it was a great space. We didn't have any, Nistan, no breaking news today, right? I wasn't monitoring well, but I didn't see GPT-5 didn't release while I was talking, right?
Nope,
No.
not yet.
Not yet. We did get one piece of breaking news that we didn't notice as we were recording the live stream, and that was from our friends in Modular. If you remember, we've talked about Modular and their new programming language Mojo, which is a superset of Python, and the creator Chris Lattner, who was previously the LLVM and MLIR compiler author, and also the creator of Swift in Apple. And we've talked about Mojo being the right language for AI, and they just released their inference engine called Max to the world in beta, and this inference engine supposedly has Mojo built in and supposedly is way faster even for existing models to run inference. So that's very interesting, and we're going to talk about more as we play around with this. All right, folks. And I think this was all we talked about on ThursdAI on February 29th. And I want to just thank everybody who joined. Nistan, thank you as always, co-host. Yam was here before, and we had Bo join for a while, even though we didn't say hi. We have a bunch of other folks. So thank you for all the guests. Thank you, all of you, for listening and tuning in from week to week. It's really a pleasure. And now with this, I'm just going to end here. Thank you, everybody. We'll see you next week. Cheers.